Whenever you are searching for any URI or URL, right, like in google.com or facebook.com, the system is doing some magic at the back end. So what it does is the magic is done by DNS, which is the domain name system. Okay, so we will explore more about DNS, how it works, what's the issue, and in the distributor point of view, what trade-off it has, or it what trade-off we need to keep in mind while building DNS system. Okay, so very thing we need to understand that we as a human speak in the name of the browser or the services, right? Like example.com, google.com, facebook.com. We remember the name, whereas we know computer remembers the number. So to translate this human readable URL to IP address, which is understood by computer, we need DNS. Let's talk about the player who involved in DNS query, right? How who plays important role. One is client, of course. A user sends a request to browse the google.com, and it then there's another resolver who try to immediately sends the resolved IP addresses to the browser based on what user requested. And then there's a root name server. So basically it keeps track of a top layer domain like example.com.org, and then after that the top layer domain keeps track of authoritative namespace, where you will find the information about or record about example, right, example.com or google.com. So let's understand a bit with the flow diagram how it works. So very first thing, it start with the user query. User says, oh, resolve www.example.com, and it is received by our system, a browser. If the browser finds it out, if it is stored in the cache in the browser, then immediately we will send our request to the that particular IP address. If it's not found, what resolver does, resolver sends this query to root name server, because resolver keeps a track of root name server, and now root name server tries to find from its on cache. If it finds the information of the example.com, then good, it will return back to the resolver. If not, it will go back to .com name service, and saying that, oh, I couldn't find the example.com. Do you have example.com information? Right now, .com name service will see into its on cache, and it returns tells that, okay, I found where this example.com might be stored or recorded to, which will basically authoritative name server, and from there our resolver receives that information and sends back to the authoritative name service. So here what happens, see, the resolver sends www.com to the IP address of resolver, and the name server sends the actual IP address of the www.google.com or example.com back to the resolver, and then resolver sends the host address to client, and client renders back. So in the case of worst case scenario, when name service doesn't have a caching, it looks up. The looking up process is too time consuming, or it's very slow, right? Like, and if, let's say, for example, user has a lot of requests to do, then it will be very time consuming. So the best thing, as I said, the caching is the only key that resolver maintains. So first, let's say when user make a request, it finds the web server browser looks into the web cache. If it has already made a request before, high chances are that you'll find the information there. If not, it goes into operating system cache. If it finds there, good. If not, it goes back to resolver, and resolver cache. If it's found still good, otherwise it will make a new request iteratively or recursively, depending upon which algorithm we are defined in DNS, and then we get back the response of IP address of www.example.com. Time to leave is kind of time given to DNS to keep record of that particular mapping. Okay, and the cache stores those mapping for that particular period of time. And let's say if the time to leave or time to store that mapping is shorter, then we will make frequent call or lookup using those iterative process or recursive process to resolve IP address. If somehow there is a change, there is update update for IP address for that particular server, right, or so the service or the google.com, we will frequently get that information. That's why it's a high agility. So with the short TTL is that it increases the load on name server. Why? Because the cache is getting outdated because TTL is low, and that's why we have to make another new request to get the updated updated IP address of the service. Whereas when we talk about a long TTL, yes, it reduces the load in the name server, and it increases the speed up because it's already stored in the cache. But the problem is the propagation for a new IP address is slower, right? It eventually comes, but it will not be immediately updated. It is eventual consistency, not strong consistency. It doesn't have strong consistency, and it's okay for DNS to be a little bit slower, to still use previous IP address, as long as it's available. Um, it is not reliable. Like for example, if we send a request to find google.com, if it if the packet or the request is dropped in between, there's no guarantee. We have to make a request again, right? That's the downside of UDP. Downside of UDP, you choosing UDP over TCP, because it's fast. It has the low overhead or low load on our server, right? DNS was designed to be distributed. The reason is, if DNS is not designed to be distributed, there's a high chances that there will be a single point of failure while resolving the IP address. Meaning, let's say the IP address DNS, the single DNS server, right? And by any chances, if it drops, if it fails, we will never be able to resolve google.com, and our user will panic. The system will be down, and there will be losses for the money. And as I said, eventual consistency is because IP address is updated for google.com. The changes will propagate through time, not immediately, but eventually.